Welcome to part 9 of the MSP432 MCU's training series. In this section, we will take a closer look at a very specific topic, that is to port code between MSP430 and MSP432. So you might be particularly interested in this section if you have an existing MSP430 or 432 project that you need to port to another platform. So in this section, we will cover how code compatibility is covered between MSP430 and 432 at different levels. Register access, driver library code, how interrupts are being handled, and how different MSP and intrinsic are being covered across the platform. Hopefully this section will give you an overview of how to port an existing application from one platform to another. So first off, the MSP platform provides high portability across the 16 and 32-bit families. At the high level, these are the different components of the hardware, software, tools, and development kits ecosystem of MSP430, and we have done quite a bit of work to make sure that these components of the ecosystem are also usable across MSP432. As you can see, many of the components are reusable across MSP432. The only thing that doesn't really migrate well is the MSP 16-bit core, obviously because that is replaced by a Cortex-M4 core. So let's take a closer look at what's being reusable, what's fully compatible, and what is extended for MSP432. So obviously any of the existing MSP430 modules such as TAMA-A, ADC, or EUSCI communication modules are 100% compatible across the different platforms. New peripherals or peripherals inherited from ARM, such as TAMA-32 or MicroDMA, will be different from MSP430 counterpart. This also gets translated over to the register level code as well as driver library code. So as you can see in here, existing MSP430 peripherals will be reusable, while the new MSP432 as well as ARM peripherals will require new code. Intrinsics and interrupts are also different from a device level. However, with the help of software and compilers, we can actually bridge the gaps and make it a little bit more similar between MSP430 and MSP430. Moving on to the development tools and development kits. As you can see, many of the existing tools and kits are reusable across different platforms thanks to the extra work that we have put into ensuring the compatibility at the hardware level as well as software level on MSP432. As an example, the ultra-low power tools such as EOP Advisor or Energy Trace have been extended from MSP430 to also work for MSP432. The highly compatible MSP ecosystem consisting of hardware, software, development tools, and kits will allow developers to easily reuse their projects, their code across the 16-bit and 32-bit MSP platforms. Let's take a closer look at the code compatibility across MSP430 and MSP432. So we break it down into different components of the peripheral, starting with core system. These are the core modules that are necessary for any devices, such as the core, the CPU, power, clock system, memory, and so on and so forth. These are the ones that will always be new when you move from one family to another. This will require the most amount of work to port from any existing platform to the next. This is also usually the area where a lot of innovation has been put into place to feature new technology to improve power consumption, performance, or even new memory technology. So for these reasons, obviously these new features will require new software solutions in order for the developers to fully leverage and take advantage of the new features. Most of the porting work will need to happen at this level. Moving on, intrinsics are the helper functions that are really specific to a CPU architecture. So usually for a given platform such as MSP430 16-bit architecture, there are specific intrinsics that only work for MSP430. Similarly, for MSP432, which is a Cortex-M4 device, there are specific Cortex-M intrinsics that usually only work across Cortex-M devices. However, with the help of our intelligent compilers as well as header files, we have been able to merge many of these changes to allow many existing intrinsics on MSP430 to also work on MSP432. This will allow existing MSP430 developers to just copy and paste their code over the MSP432 and make minimal changes in order to get things to work. Moving on to the peripherals, there are two types of peripherals. First off are the MSP peripherals. So these are the same ones we have on MSP430 today, such as TAMA-A, EUSCI, GPIO, ADC, and so on and so forth. So many of these peripherals are 100% identical across MSP430 and MSP432. And for those, you have 100% code compatibility. That means you can just copy and paste the code over from one platform to another and it should work. One thing though to keep in mind is that because of the 16-bit versus 32-bit architecture, make sure that the data types are applicable to your specific platform. When in doubt, use explicit types such as C99 type. Some peripherals will be slightly updated, such as ADC14 versus ADC12. For those, some minor modifications might be required. If your application code consists of mainly these peripherals, chances are you will need to spend very little time to port your code from one MSP to another. Moving on, the second class of peripherals are the ARM peripherals, such as DMA, Time32, or SysTick. Since these peripherals are brand new to MSP, we simply don't have existing code today on MSP430 that can be reused on MSP432. However, the same code can be found on other TI ARM MCUs such as Tiva-C. Last but not least, the main application code is usually the higher level software that is not too dependent on the architecture itself. If developers utilize with proper software development techniques and sufficient abstraction layers, the application code should not vary too much between MSP430 and MSP432 platforms. However, one thing to definitely keep in mind is the data type. In order to prevent any misuse of data types between 16-bit and 32-bit, try to use explicit C99 types whenever possible. Here's a quick example of how direct register access code works across the different platforms. As you can see, this is a small piece of code that configures the timer A module and turns on the interrupt. You can see that most lines of code are identical across MSP430 and MSP432. The only difference here is how you enable interrupt and how you go to low power mode. Similarly, when using driver library code for existing peripherals that are shared across MSP430 and MSP432, the code looks 100% identical. Next, many of the existing MSP430 intrinsics are now supported on MSP432 platform with the use of the intelligent header file as well as the flexible compiler, especially inside Code Composer Studio. So many of the existing intrinsics such as no operation, low power mode intrinsics, as well as more advanced intrinsic functions such as delay cycles are now also supported inside Code Composer Studio. For the particular intrinsics that are really specific to 16-bit that are no longer usable in MSP432, the compiler actually detects all of these unusable intrinsics and flag it and provide guidance for developers to go through the replacement process. For more information, open the MSP Compatibility .h file that is part of the standard MSP432 header file for more information on these intrinsics. Finally, let's take a quick look at how interrupts can be handled across MSP430 and MSP432. If you recall, MSP432 is a Cortex-M4F device, and for that reason it uses the Nested Vector Interrupt Controller, or NVIC, which is a big step up from MSP430 interrupt module. NVIC allows you to have configurable priority interrupt, as well as enhancements such as tail chaining to improve the latency between interrupt services. For a typical Cortex-M device project, usually the interrupt vector table is defined as a separate table in a separate file, as you can see on the left hand side. So in here you will plug in the interrupt handlers that you need for your application. So by default, this is the method that is supported for MSP432 across all of our compilers and IDEs such as TCS, IAR, or Kyle. On the other hand, the traditional MSP430 method is to use a pragma vector. In this case, you don't need to define the entire interrupt vector table. In fact, you only need to specify the vectors that you actually use using the pragma vector interrupt. You can also trap the unused interrupts using the same pragma vector. So the challenge here is, how do I copy my MSP430 code to MSP432, particularly for the interrupt service routines? Well, the good news is that both methods are supported on MSP430. If you are starting out on a new Cortex-M project development, you can definitely use the option number 1 on the left to define your interrupt vector table. However, if you have an existing MSP430 application that you want to reuse the interrupt service routines on MSP432, or if you want to develop an MSP432 application that you want to eventually port over to MSP430 platform in the future, you might want to use option number 2. These options are mutually exclusive, so if you have an interrupt vector table, make sure not to use the pragma vector or vice versa. Another thing to note in terms of interrupt usage on MSP432, and that is particularly important for existing MSP430 users, is that on MSP430, the interrupt controller is part of the CPU, so no extra handling is required. However, on MSP432, the NVIC is the actual module that sits between the individual peripherals and the master interrupt. So on MSP432, you need to do 2 steps. One is to enable the interrupt triggers at the module level and then enable the master interrupt. However, on MSP432, there is one additional step that you need to do, and that is to map the individual module interrupt onto the NVIC table, essentially enabling the module interrupt on the NVIC level. This is step number 2 as highlighted below. Vice versa, if you need to port an existing MSP432 application back to MSP430, make sure to remove step number 2 because it is no longer relevant on MSP430. So with that, we have concluded the part 9 of the MSP432 MCU training series. Hopefully this session gave you an overview of what it takes to port an existing application from one MSP platform to another. Some of the things that you need to remember are whether you use a register access code or driver library, how to handle interrupts, how to handle intrinsics, and some of the gotchas you need to do when porting from 16-bit to 32-bit and vice versa. Thanks for watching.